Okay, welcome to everyone, and thank you for joining for this short introduction of Indrivetec and power electronics equipment we build and offer. Some words, Indrivetec was founded in 2013 here in Zurich. So here we have our headquarters. We are a technology company in the field of power electronics. We develop power electronics, controls and everything in-house. We produce them in our own factory facilities in Bulgaria and in Zurich. And we have additionally offices in Hamburg and Berlin for business development and engineering as well. So in short numbers, so the people working here are several ones are working since more than 25 years in the field of power electronics. We have more than 105 members, so a bit and around 30 here in Zurich, then 65 plus in Bulgaria, and then in Germany. So we have quite some projects installed, equipment installed worldwide. So Europe, America, Asia, Africa, Australia, so worldwide. As mentioned, we design and develop our equipment by ourselves. So we produce them in our facilities, and we have quite some test infrastructure. So here in Zurich, we can test power electronics up to 1 megawatt. We have a heat chamber. We can do all kind of insulation testing and power runs. Then in our facility in Bulgaria, we do have a 6 MVA or 3 megawatt test stand, so we can run active and reactive power up to this level, so up to 1500 volt DC, 690, 900 volt AC, and fully test our equipment. Our main fields of operation, so the one is energy storage systems, used and applied in renewable applications, grid support, and so on. Then industrial drive inverters, big drives up to 18 megawatt for mining applications like ball mills, rock crushers, and this kind of equipment. Then, of course, linear motor drives for roller coasters. So here we design and produce linear motors. So we manufacture them here in Zurich, actually. Then the power electronics driving these motors is as well our own equipment. And here we offer the total, let's say, set from grid connection, drives, energy storage, and motors up to, let's say, 9 megawatt and more per roller coaster. They are installed worldwide as well. And yeah. Then additionally, we have a special purpose equipment. Let's say we design and develop power electronics if you have a special application, if it's AC/DC, DC/DC, and so on, from, let's say, 100 kilowatt up to multi-megawatt. Then in the power electronics, let's say go a bit into this direction. There we have, let's say, the two-level inverters, 690 volt AC up to 1100 volt. There's some automatic change. Sorry for that one. Then three-level inverters. So I think I have to change here now. Then So back into this power electronics, so 2-level inverters, 3-level inverters, and DC-DC. 2-level up to 1100 volt, 3-level to 1500 volt DC. We go now more into details for each one. So on the 2-level technology, based on IGBTs, that's our own product as well. They're typically built into battery inverters from 300 kilowatt up to 2 megawatt per device. Here you see a picture of a 1 megawatt auto-rated battery inverter connected to up to 1100 volt DC batteries and to 400 volt to 480 volt AC. On the single line diagram, you see all kind of equipment in here like disconnections, filters, filter inductors, power electronics, power stacks. And these core elements basically are, let's say, converting AC into DC and vice versa. Such a AC-DC power stack, power electronic stack, looks like this on the top left here. So this is designed and built at Indrivetec. You see here IGBTs, power semiconductors, and here a typical schematic or graphic how it looks like in function-wise. So you have here semiconductor switches. Here you have the DC voltage side with the DC link. So here you connect then the batteries, for example. On the other side here, you have, for example, the grid connection, AC 3-phase. Then the capacitors are these pans basically here. That's this part. And each switch can be turned on and off depending on the required current and voltage you need on the AC side. And this works in both directions, so DC to AC direction or AC to DC direction. Here you see a graphic, a plot of how it looks like. So you have here the sine wave. That's basically the currents and the voltage. And then you have as well, the blue one is the PWM. And if you have, for example, here 1000 volt DC on a battery, you can then turn on switch 1, then the current flows through this phase to the load or to the grid and comes back to another phase. And if you turn on switch 6, then it goes back like this. And you have a, let's say, closed loop. Then depending on how much current you need, you can pulse width modulation wise turn on and off them with in the kilohertz range, and then you get this kind of signals and PWM functions and curves like shown here. So you see here in the end you can modulate the currents and voltages as you need. So that's the 2-level topology we use in our equipment. Then we have the 3-level topology and technology. So this we use for up to 1500 volt DC. Here on the picture on the left side, you see a 2.1 megawatt inverter as well, auto-rated. It's fully liquid cooled. And again, a typical single line diagram, how it looks like. You have basically similar equipment in disconnection, filtering, and again, power stacks, power electronics. And this looks now like this. So this is a 3-level power stack. And 3-level means now, as you have higher DC voltage level up to 1500 volt, you can divide the voltage into, let's say, smaller steps. You can have the DC link split into 2 parts, as you see here. For example, 750 volt on this side and 750 volt on that side, physically built up with capacitor cans, as you see here. Here we have the IGBT switches, semiconductors, marked here 1, 2, 5, 6, and 3, 4. So with this technology, you can achieve higher voltages as well with this ANPC active neutral point clamping technology. You can modulate instead of like shown before with a full 1000-volt a DC voltage turn on and off. You can have now steps, so you can do 750 volt or 1500 volt, and you can build up, let's say, make smaller steps and blocks. In the end, if you do a modulation, for example, you can turn on, for example, switch 1 and 2. Then you have this voltage of the plus going to the load or to the grid, comes back to this one. If you turn on this on the bottom, then you have the full voltage on it. You can do now as well half voltage in case you turn on, for example, switch 5 and 2, and then goes back to the like these two again. So you have full or half voltages. And you can do this in both directions, plus and minus. In the end, you get currents as shown here. So you have, let's say, less ripple and higher frequencies because you do intermediate steps as well. So in the end, you have to invest a bit more in power electronics, yeah, but you can save then on the filtering side and achieve, let's say, higher efficiencies. Then we have as well DC-DC converters used for battery applications as well for others. You can use them to connect different DC voltage levels, technologies, and so on. For example, there are battery technologies with quite low voltage levels and high currents, and to operate them with, let's say, our standard inverters connected to 400-volt grid or 690-volt grid, you can boost up the voltage. This here is a typical cabinet air-cooled of a 500 kilowatt DC-DC converter. Here as well, let's say a simple single line diagram, connections, disconnections on both sides, as well as power stack and filtering. And a power stack air-cooled looks like this on the top left. So here again, we have capacitors for to build up the DC link for filtering, and in additional here, the IGBT semiconductor switches. Looks like this and a setup. Here we have as well, let's say, can do the modulation. And if we, for example, turn on this switch on the top left, it goes to the load, comes back and goes to the down here through this one. Then you have the positive voltage applied. If you switch on vice versa, then you have the negative voltage applied. And depending how you combine the switching, you have as well both direction power flow, and you can control the currents and set the voltage. And this technology we have on both levels, let's say 1100 volt DC max or 1500 volt DC max. Okay, so now this before shown power electronics is used in our battery storage inverters. So we have the 1100 volt inverters, PCS, power conversion system, up to 3.3 kVA or 2 megawatt, 2.2 megawatt. Then the 3 level on the 1500 volt inverters up to 4.9 MVA or 4.3 megawatt. Then in addition, if you combine those inverters into a, for example, pre-assembled container solution, then you have a PCSU, power conversion system unit, where you have integrated inverter, EMS, and so on. Just a short overview on the ratings. So the smallest in the battery inverters is the FC320, going from 120 or 220 kilowatt up to 460. The biggest one goes up to 3 megawatt, depending on the voltage levels. So here we have 6 different size of inverters, steps by, on the lower side 250 kilowatt, on the higher side 500 kilowatt. Typical pictures, indoor solution, outdoor solution. You have seen this one on the right side in the pictures before. To be mentioned is as well, these inverters from 500 kilowatt upwards, they are all fully liquid cooled and fully enclosed. So you just have to connect cooling water, it's water glycol mixture, and then you get rid of all the losses through the liquid. Has advantages if you install them indoors. So your HVAC system, air conditioning, you can basically just put in a small air circulation. You don't need active cooling. If you put it outdoor, just have to add on heat exchangers, and then you have the whole equipment, the whole device in one block. Then on the 1500 volt PCS, these are with the 3-level power stacks. So here we go from the FC 1440 from 800 kilowatt to the biggest FC 4320 up to this almost 5 MVA, as well depending on the voltage levels, AC or DC side. Here a typical outline and pictures of such a cabinet. So it's outdoor rated. This one is an outdoor rated unit. Here you see a picture of how it looks like. So here we have the power stacks as shown before, the filtering inductors, AC, DC connection, and so on. Here on the right side, we have the heat exchangers to cool down the liquid water glycol mixture, what is cooling the inductors, the power electronics, and the air inside the cabinets. And this is the integrated PCSU. So you have, for example, here an inverter. You have energy management. You can have here as well the medium voltage transformer. So it's a pre-assembled unit. And then in addition to this, you just place battery containers or outdoor racks. So that's one of the solutions we offer. Then, if you want to have all-in-one, not just the inverter and transformers as well, batteries included, then there is, let's say, for example, typical 20-foot application, 20-foot sea freight container sizing, or 40-foot sea freight container. Here, this cabinet, this is a 2 megawatt inverter. Here we have the battery racks, the energy management, and here, depending on the size, you can put in transformers or the HVACs. So here we go on the smaller one, on the 20-foot, up to 1 megawatt and 1.2 megawatt hours. On the 40-foot, 2.2 megawatt or 2.4 megawatt hours. That's the current state. These ones you can operate with 0.5 C or 1 C, up to 1 C. So for primary power control, frequency control, such kind of applications. Then the PCSU, as seen before, all integrated in a container, and then you have a plain battery container. Here you can place as well, as shown later on, 20-foot, 5 megawatt hour containers. That's completely different application, a different setup. You can combine this like this as well. So instead of before shown lithium battery application, so the ones before have been all with LFP batteries. Here is a solution with natrium sulfur batteries, high temperature batteries. It's kind of an energy battery. So you have here, it's up to 6 times ratio, so it's 0.17 or 0.2 C. Here the battery containers, they don't need air conditioning, whatever, so they are quite robust. You can place them in a harsh environment, in deserts, whatever, as the battery temperature is on almost 300 degrees C. And then here you have, for example, such a PCSU unit where you have in the inverter and all this equipment, and you can combine this. So you have here in this setup 1 megawatt and 5.8 megawatt hour with this technology. Then some battery racks, indoor rated racks. So typical 1100 volt, 150 kilowatt hour up to 1C. Then up to 1100 volt and 280 kilowatt hours as well up to 1C, 0.5 or 1C. And then on the right side, 1500 volt racks, outdoor rated as well with 372 kilowatt hours. So it's all integrated. You have the air conditioning, you have the BMS, it's all in. Then, as mentioned before, we have battery containers like these ones here with LFP batteries. So this is shown a 3.4 megawatt hour, 20-foot container, battery container. This one is as well available as a 5 megawatt hour battery container, but C-rate up to 0.5. So, and you can combine this then with all kind of inverters we offer. So the triple solution, that's with the 1500 volt technology, 3-level. We have here as an example 2.1 MVA outdoor inverter, then the outdoor battery racks and the energy management, as well as an outdoor cabinet. This can be used as well as a plant EMS, and you can combine this then to such kind of setups like here, inverter in front, energy management, combiner cabinet for the outdoor racks, and then lineup of the outdoor battery racks. And this you can combine in all kind of settings, C-rate 1, 0.5, and yeah, up to 9 megawatt hour per block. If you take now the 20-foot container with 3.4 megawatt hours or 5 megawatt hours, you can combine it in a similar way. Outdoor inverter, battery container, and the EMS. And then you can combine it like this. You can as well put 2 of such containers to 1 PCS. So then you have 10 megawatt hours and so on, depending on your ratio from power to energy. And you can combine it and set it up. So this is kind of a, let's say, easy to design and kind of a modular system. So depending on your application and requirements, it can be quite good adapted. Then in addition, as seen before, the cabinet, so the energy management system, it's an important part of such a battery storage solution, because there has to be some kind of control. There we have on-grid solutions or off-grid. On-grid, you can do all kind of energy trading, peak load shaving, frequency regulation, primary, secondary power control, and so on. And on the off-grid solutions and applications, so you have the black start possibility. So all of our equipment is island mode or off-grid capable, including black start. Then with this, you can, let's say, build up your island grid. You can combine it with PV, with wind, and as well gensets to have your own island operational. If you operate it as a, let's say, island from as a base design, you can as well combine it, let's say, to have it as an on-grid system, and then in case the grid goes off, to change into off-grid operation. So like a kind of UPS functionality. So to keep your systems and your facilities, whatever, in operation. Here you see a typical overview on such a EMS control page with single line of the equipment, batteries, the PCS, inverters, grid connections. So you have all kind of information here about power flow, energy content, and so on. So you can monitor and control your application, your assets with this system here as well, let's say, including touchscreen to have local control and operation. Of course, you can do it remotely as well with web application to have remote control over you. So some references on applications we have. So the one is on the inverters. The one thing is indoor inverters, as you see on the bottom right side. These are 750 kilowatt inverters lined up in a system in UK. This goes up to 49 megawatt. It's primary control application. Then as well, all kind of built-in equipment in containers, buildings, concrete stations. So these are, let's say, typical PCS applications for grid-connected functions, but as well off-grid. Then on the battery storage systems, here we have the typical 20-foot or 40-foot sea freight containers containing the LFP batteries, the inverters, and the energy management, as well energy trading, primary, secondary control, yeah, these kind of applications. Here you see how it looks inside, almost, yeah. Here, yeah. Then some other references like these natrium sulfur equipment. Here a setup, it's a 2.9 megawatt hour and 500 kilowatt application connected with PV. Here on the Greek island, the combination, here we have salt batteries from Horion combined with our PCS in combination with PV and wind energy. So it's a island application. Then other applications here as well, some natrium sulfur and others. Totally different linear motor, some roller coaster application here. It's in Scandinavia, it's Finland. Taiga, it's a double launch coaster. Here you see the linear motors, and yeah, here we have the fastest in Europe, as well a roller coaster in Portaventura Park in Spain. So it's as well the tallest and fastest one in Europe. Here we delivered the motors, and here you see the outdoor inverters basically driving or feeding the energy to the motors here on the track. So this is a spread, basically DC system, DC bus connected to grid and storage, so that the peak load is fed out of supercap storage and not coming directly from the grid. So during launching, there are multi-megawatt power is pushed into the motors, and this comes out all of out of a supercap storage, and then in the time between the launches, there the supercap gets recharged with lower power from the grid. As a mining application, that's an application I think in Australia for ball mills. This was a 6 megawatt system, and here we are at the end. So therefore, I hope you got some insights what we do and on our products and technology. Of course, this was, let's say, more on a high level, not into much details. But of course, if you have questions and interests or topics, just get in touch. So thank you.
Thank you, Martin. It was very interesting to look at all the different applications you have and also all the different systems. So the floor is open to people that want to ask any question. You can just raise your hand and I will try to unmute you, or you can also just write it in the chat. And just to give some time to people to ask a question, I have several already noted down. So first of all, I was wondering, I really like the fact that you have quite a lot of synergy that you can create between the power control or the power electronics and the storage. Is there any way that actually you can optimize, for example, battery performance and at the same time maybe minimizing losses if you operate it the power electronics accordingly, or that you can modulate the system such that you can minimize losses?
Yes, there are such possibilities. The point is how you modulate. So there are different ways how you modulate the turn on and off pattern, and what kind of technology you use if you have 2-level or 3-level, and as well as in the modulation patterns you do, but as well on the switching frequency, how fast you do it.
Yeah.
And then in combination with filters and how you operate the whole thing on the energy and the current flow. So there are many parameters where you can tweak and optimize the system. And just as an example, on the 1500 volt 3-level inverters for these big units up to almost 5 megawatt, so we reach their peak efficiency of 99%. So it's kind of optimized on the PWM patterns and filters to have high efficiency and low losses.
Yeah, great. So what is actually the durability of your system? So it depends on the application, but generally, do you offer warranty or to your system?
Yes, we have standard warranties up to 5 years and more. So the design of the equipment is done for 20 years. If on special request, about 25 years of operation time. But usually batteries, they don't last that long. So yeah, it's all kind of a trade-off on the cost side and on the requirement of the customers. But what we see now is that battery lifetime gets extended more and more as well. There are new ones with 10,000 cycles, 20 years operation. So this finds quite a nice match with our power electronics.
Yeah, I'll take some questions from the public. So first question, do you integrate virgin cell or second life cell into your battery energy storage system?
Yes, we have a cooperation with a company Libation in Switzerland, where we have upcycled or second life batteries with our products. So there is our PCS and energy management in combination. Of course, there is a CircuBAT project. We work together, and as well, this is a second life application. For example, Nissan Leaf batteries. So there we use a DC-DC conversion in combination with the inverters we do. So yes, it's second life, first life. Yeah.
Good. Maybe on the same, since you mentioned second life, first life, and maybe also different chemistry, also always Corrado Romano asking, what is the level of demand of sodium sulfur BESS? In which geography are most requested and why they are preferred over lithium ions application?
Yeah, let's say over 90% or 95% of the applications we do is with LFP, currently lithium. We have natrium sulfur batteries. There are several projects in Eastern Europe, Germany, Belgium, but these are single ones. And others are in, let's say, Arabic areas where you have high temperatures and high sun radiation and harsh environment. So there they have certain advantage in view of as you don't need air conditioning, because the lithium batteries you need to keep on a constant temperature. What you don't need to do with this natrium sulfur.
It doesn't have any impact on the lifetime?
There is, of course, as well an impact. let's say on these natrium sulfur or as well salt batteries, you need to heat up them one time to a certain level, 270 degrees plus minus. And then depending on your operation points, they heat themselves due to internal resistance. And if the ambient temperature is very high, eventually there is some derating as well. But usually up to now, we don't see much issues on that one.
So this connects us to the question from class 10. And they said, you mentioned air conditioning cooled system, but also liquid cooled power electronics. Is this via immersion cooling of the power electronics or through heat exchangers?
So we do with heat exchangers. So the losses go via liquid heat sinks from the power electronics to the water glycol mixture, as well on the inductors and others. The internal air gets cooled with air to water heat exchangers. So in the end, we have all the losses in the liquid. Then this liquid goes to a water air heat exchanger again and dissipates it to the ambient air. This works up to 50 degrees Celsius. If it's, let's say, special harsh operation or even higher temperatures, then there is derating, or another way is then to replace this water air heat exchanger with an active cooled, compressor cooled system. But usually standard water air heat exchanger works out quite well. It's as well cost efficient.
Yeah. So I still invite the attendees to ask more questions in the chat. In the meanwhile, I still have a few others. While looking at your slide, at one point you show something like a dashboard where you control your system. Is this control on all the system you sell, just on few of them where you offer maybe warranty rather than you sell directly the system? Are those data recorded over lifetime? And how those data will help you maybe to comply with the battery regulation that is requesting for you to record data?
So this depends on, let's say, what kind of package a customer needs or a system integrator needs. As we offer, for example, just standard PCS or the inverter as a standalone product, so then we don't have it. We have as well combination inverter plus EMS or then the complete one. And there, the system, there is data recording. This has several reasons, like monitoring of the operation. If there is errors or warnings coming up, then remote control to modify the way of operation. And there is data recording of operation, and as well the battery behavior and so on. So we cooperate there with a company to have the battery behavior, let's say, analyzed and monitored, so that we know as well, okay, how is battery behavior? So how is the state of health? The one thing is what the battery supplier BMS tells you, but the other thing is, can you verify it? So is it truth in this way? So yeah.
Yeah. There is another question from Upvolt, Lucas, that say, where do you sell your batteries? Which countries you sell the most and why?
So currently there's quite some projects in Netherlands and Germany. Then we have as well projects basically all over the planet, let's say. For example, in Africa and Australia, we have these natrium sulfur batteries. In Europe, usually LFP. Applications are there combined with PV. That's the one thing. Others are as well, especially in the Netherlands, as their grid is kind of on the limit, let's say. And as they go now, let's say, electric on logistics with trucks and others, they install, for example, PV on logistics buildings. Then we place battery storage, megawatt hours, so that they can charge this storage through the day with the PV. And in the evening, when the trucks comes back to the warehouse, they recharge then the trucks out of this buffer battery storage. So these are real applications what are already in operation, and others are energy trading, as a kind of used as an investment this way as well. Grid stabilizing.
Yeah, you say that you had plenty of application, right? I think, and I don't know if you have data about what is the most rewarding one or the most worth it application.
That's difficult because, we are equipment supplier, we do not operate them, and
So this is not a business case for you. So something like battery as a service that you offer it. Always from my side, I was thinking, you are mostly operating in the stationary, for stationary storage. Have you ever thought about going into mobility, but more for high power, high energy, like maritime or marine application?
Currently not, no, because there you need as well additional certifications and cover additional requirements. So this is a general topic.
Okay.
Yes.
And you already talked about change of chemistry that will not impact much. Do you already see a switch towards what we always heard, that sodium ion will somehow try to replace LFP? Or what about the new generation of LFP to high voltage spinel LFP?
So currently we see, let's say, 1500 volt LFP as a kind of a standard for all kind of applications. So not only the, let's say, utility scale projects as well as smaller ones. Sodium ion probably takes some more time, and there are some other topics to be considered, as, let's say, the voltage variation is much higher than, let's say, discharged and fully charged. So it has some additional, let's say, requirements in regards of power electronics. So you need to adapt to this. So currently, let's say, next 1-2 years, probably LFP is the one, the most used one now.
And did you ever consider some kind of hybridization of different chemistry, since actually you can control quite well voltage level of the system? So I don't know if there is any business there to combine different one to make it power or energy accordingly.
Let's say right now, as let's say the LFP battery prices are so low,
that
you just
there
place
is nothing
more,
else.
And then you have more power and more energy. That's the one thing. Also, we are in a project with such kind of hybridization. For example, salt batteries combined with supercaps, or redox flow combined with supercaps. So there we do the power electronics to combine them and operate them. So to have, let's say, the short-term high power capability out of supercaps and the energy content then of redox flow or salt. So we do as well such hybrid projects. And the advantage there is that all comes from Europe, so it's not depending on China, let's say. But on the cost side, currently difficult.
Yeah, so I think I'm over with my question. If from the public you still have some you would like to ask, please do so. Otherwise, yes, I think I'll just wait 1 minute more. And otherwise, thank you very much, Martin, for a very nice presentation and showing us all the different applications and all the products you have. And yes, good luck for the futures. I think it will be bright. And yes, we keep in touch. And for all the other attendees, we will have the next iBattery Tuesday in a month from now. And you will have information about next speaker from iBAT management. Thank you very much and have a good afternoon.
Thank you, Sal, and have a good afternoon. Take care. Bye.